Welcome back to today's video episode on Chemistry Made Easy with Bright Edu. In today's video lesson, I'll be teaching on one of the gas laws, and it is called the ideal gas equation. Now, in the course of today's class, I'll be bringing out the equation used to solve questions under this aspect, and I'm going to tell us the meaning of all the parameters and when to use these parameters so we start solving questions as soon as possible. Now, to solve questions under the ideal gas equation, there's a formula that must be noted. And what is the formula? It is simply PV is equal to nRT. So the question asks me, what is P? What is V? What is N? What is T? And what is R? Now, P simply means pressure. What does V signifies? V signifies volume. What does N signifies? It signifies number of moles. And what does T signifies? It signifies temperature. And the temperature SI unit should be in Kelvin. But most times we'll be given the temperature in degrees Celsius. So we simply convert degrees Celsius to Kelvin. So to do that, you just say degrees Celsius plus 273, you get the answer in Kelvin scale. So basically, these are some formulas that must be noted. Now, most importantly, what parameters do we need to understand better? This is the parameter, and it is called the molar gas constant. Okay, this is called the molar gas constant. Okay, it is called the molar gas constant. And if you don't want to call it the molar gas constant, you can call it the ideal gas constant. The molar gas constant or the ideal gas constant. Now, it is actually a constant. And what is the constant? Now, for the O-level chemistry, we need to just master two of the constant. Actually, we have up to 6 constants. But for O-level chemistry, which is Jamb level, post-UTME, and white level, we just need to master just 2 of the constant. And what are the constants we need to know? The first of them is called the 0.08205, and the other is called 8.314. These are the 2 constants we have to master. Now, the question asks me, when do we use this constant when solving? And also, when do we use this constant when solving? Now, we use this constant, which is 0.08205, whenever the pressure given in the question is in ATM. What is ATM? ATM means atmosphere. Now, we use the same constant whenever the volume given in the question is in dm cube or liters. This is when we use this constant. So for we to use the constant, which is 0.08205, the pressure should be in atm and the volume should be in dm cube or liters. So when do we use this constant, which is 8.314? We use this constant whenever the pressure is in Newton per meter squared, or you say Pascal. So this is the SI that the pressure should be in when we are to use this constant. But when do we still use this constant? We use it whenever the volume is in meter cube. Okay, so in the course of today's class, I'll be teaching us on how to basically convert millimeter mercury, which is one of a pressure SI unit, to ATM and also to Newton per meter squared, because most times the pressure given in the question will be in mmHg. So we have to convert to either of these SI unit so as to get the answer and use the correct SI unit. So next point, let's quickly deduce out the SI unit for the constant, which is 0.08205, and also deduce the SI unit for this constant, which is 8.314. But most importantly, For this level, we use this constant more than this constant. We use this more than this constant. But basically, when we use both constant, like we impute this constant in the formula and use it on the basis of this requirement, we'll get an answer. If we still use this constant, we get the same answer. But it is best for we to use this first one. It is easier to solve. So moving further, let's quickly deduce out the SI unit for this constant, which is 0.08205, because it has an SI unit. Now let's quickly deduce out the SI unit for this constant, which is called the molar gas constant, from all of these informations. Now let's quickly make it subject of formula in this formula. So it becomes PV is equal to nRT. So we divide by the coefficient of R, since we are making it subject. We divide both sides by the coefficient of R. So what are the coefficients of R? It is NC. So we divide and cancel. So basically, when we write arrow, it becomes PV all over NT. So you can see out, or you can see the equation for solving arrow. But recall, we are trying to deduce out the SI unit for this constant based on this requirement. So what is the SI unit for pressure for this constant? It is ATM. What is the SI unit for volume for this constant? It is dm cube or liters. So let's just pick one of them and use dm cube all over. What is the value of the SI unit for number of moles? It is just moles. And what is the SI unit for temperature? It is Kelvin. Okay, we'll be using Kelvin in this case, so just write K. So this is the SI unit for this constant, but it can be rewritten as ATM times dm cube per mole. Divide sign means mole. You can see I've written for ATM and dm cube. So the next of them is this and this, but it will be per. But in the course of this, we'll just write it as mole raised to the power of -1, because we are dividing, okay, indices, times Kelvin raised to the power of what? -1, because this is still under. But now, we now write this here to be 0.08205. The SI unit now is now ATM times dm cube per mole per Kelvin. So you can see how the SI unit for this constant actually works. But this is still very important, but you have to take note of this constant, which is most important. So let's quickly move over to solving past questions under this aspect, because I said for we to use this constant, the pressure should be in ATM and the volume should be in dm cube or liters. But for we to use this constant, the pressure should be in Newton per meter squared or Pascal, and the volume should be in meter cube. This is something we must take note of. So in the course of solving questions, I'm going to teach us how to convert this pressure and volume. Now let's quickly move over to the first question for the day. Now the question says 350 cm cube of an LD gas. Now there's something you must take note of here. Now to know the formula to actually use when solving questions under this aspect, you have to check the statement in the question very carefully. Now you can see here they said 350 cm cube of an LD gas. So whenever you just see the word LD gas, what comes to your mind is the LD gas equation. Now, exert a pressure of 1.05 atm at 37 degrees Celsius. What is the amount in moles of the gas present? So first of all, we just saw LD gas. So what comes to our mind is the what? LD gas equation, which is PV is equal to nRT. So from the question, what are they asking us to calculate? What is the amount in moles? That means they are asking us to get number of moles. So number of moles becomes PV over RT. That is number of moles. Secondly, recall I told us the meanings of the symbols. Recall P is pressure, and pressure here is in ATM. V is volume, and volume here is in cm cube. T is temperature, and temperature here is 37 degrees Celsius. Now let's bring them down. So P is 1.05 atmosphere, which is atm, and V is 350 cm cube, and and T is 37 degree Celsius. Lastly, I told you we use that first constant, which is very easy to use. Though when we use the other, we get the same answer. But let's use the order of the constant, which is 0.08205. Recall the SI units: ATM times dm cube, moles raised to the power of -1, and Kelvin raised to the power of -1. So this is the SI unit for this constant. Now recall, I said for we to use this constant, the pressure should be in ATM. So we are already safe with the question because they already gave us the pressure in ATM. So this is okay. We can use it. You can see that the pressure is in ATM. The volume should be in dm cube. Now let's check the volume. The volume given is in cm cube, and we already see that the volume we should use here is in dm cube. So what are we to do to convert this to dm cube? So how do you convert cm cube to dm cube? It must be noted that 1 dm cube is equal to 1000 cm cube. This is something we must take note of. So the dm cube we are asked to calculate for is x is equal to what they gave us in the question, which is 350 cm cube. So we cross multiply. So when we cross multiply, we make it sub there. X dm cube becomes 1 dm cube times 350 cm cube all over 1000 cm cube. So what becomes x dm cube? It is 0.35 dm cube, because cm cube cancels cm cube and 350 divides 1000. So the value should include here is 0.35 dm cube, not this, because the SN told us that our volume should be in what? Dm cube. So here is 0.035 dm cube. So this is the best to be used. Record the SN for the temperature should be in Kelvin, not in degrees Celsius, but we'll convert this to degrees Celsius. Recall I gave you an equation earlier that says degrees Celsius plus 273 is equal to Kelvin. And what is the value for degrees Celsius? That's 37 degrees Celsius plus 273 is equal to 310 Kelvin. So you can see how it works. So basically, let's input the parameters. N number of moles become, what's the pressure? 1.05 atm. ATM times what's the volume? The volume given in the question is 350, but I said we have to convert it to dm cube, which is 0.35 dm cube over what is the constant, which is molar gas constant. It is 0.08205 atm times dm cube per mole per Kelvin times the temperature, which is 310 Kelvin. So you can see how it works. Let's divide first. We get 1.05 times 0.35 all over 0.08205 times 310. So we'll press this in our calculator. We get the answer for the number of moles which are asked to calculate to be 0.0144 moles. So what becomes the answer in this option? Option B is the correct answer to the question. So you can see how problems under this aspect are being tackled. Now let's quickly move over to the second question. So after solving the second question, the third one you solve and you provide the answer in the comment section below. Now let's quickly move over to the second question. Now the question says, calculate the number of moles of an LD gas. So this formula comes to your mind, which occupies a volume of 270 cm cube at a pressure of 740 mmHg, which is called millimeter of mercury, and 28 degrees Celsius. giving the molar gas constant to be 0.08205. Now, let's quickly make some corrections to this question before we start solving. Recall I said that the volume should be in dm cube and the pressure should be in atm. Recall they are still asking us to calculate number of moles. So we simply bring it down. So we say number of moles is PV all over RT. The pressure in the question is given to be 740 mmHg and the volume in the question is given to be 270 cm cube. But we need to convert to ATM. We need to convert to dm cube as stated by the SI unit of the molar gas constant. So how do we convert mmHg to ATM? It is very easy. We simply bring this down and say it must be noted, you must take note of this conversion factor. It is 1 ATM is equal to 760 mmHg. 1 ATM is equal to 760 mmHg. So what happens next is to bring out what the asking us to get. So we have to convert to the ATM now, the new ATM, to make it X ATM. Recall to convert, you have to basically bring out the correct conversion factor of both parameters and bring the other ones you're asked to convert to down, as seen here, the normal one and what they asked us to convert to. So XATM to give us what they give us in the question, which is 740 mmHg. Make sure that all of them are in the same sides. So cross multiply. So XATM becomes 1 ATM times 740 mmHg all over 760 mmHg. So XATM becomes that 740 all over 760. Okay, 740 over 760. 740 divided by 760, that is 0.974. Okay, 0.974 ATM. So let's quickly convert this to dm cube. Recall that 1 dm cube is equal to 1000 cm cube. So x dm cube, which we are asking to convert to, is equal to 270 cm cube. Cross multiply to x dm cube will now be equal to 1 times 270 all over 1000. So let's do that and get the answer in dm cube. That is 270 all over 1000. That is 0.27 dm cube. So we simply bring all of this into the formula. And now, because the pressure now, the new pressure, not the value in mmHg, but the value in ATM, which is 0.974, okay, times the volume now 0.27 all over the R now, which is 0.08205, times the temperature. Now the temperature should be converted to Kelvin. Recall to convert temperature to Kelvin, you see degrees Celsius plus 273 is equal to Kelvin. So definitely 28 degrees Celsius plus 273 is equal to, that's 270 plus 28, that's 301 Kelvin. So we simply bring it here, 301 Kelvin. So number of moles becomes, that's 0.974 times 0.27 all over 0.0205 times 301, that is 0.01065 moles. So you can see this is the number of mole of the LD gas that will occupy a volume of this and a pressure of this and the temperature of this, basically using this constant. So you can see how questions under this aspect are being tackled. So the next of the questions here, you'll be solving it and you provide the answer in the comment section below. Now, this is the question you'll be solving and you provide the answer in the comment section below. Recall, I said for you to use this molar gas constant now, given the question, your pressure should be in ATM. And the pressure they gave us here is in mmHg. So you have to convert to ATM as seen in the previous example. And the volume should be in dm cube. The volume here is in cm cube. This is 600 cm cube. Okay, this is 600 cm cube. Okay, 600 cm cube. So basically, When you apply the same formula, you're going to get the correct answer to the question. You can see the options here. So you choose the correct answer and provide the answer in the comment section below. Thank you very much.